Welcome to Civil Engineering Edge. Today, we take you inside one of the most extraordinary engineering creations ever built, the largest self-supported hall on Earth. Hidden deep in the forests of Brandenburg, Germany, this megastructure rises like a futuristic dome from another world. It's a hall so massive you could stand the Statue of Liberty upright inside it and lay the Eiffel Tower on its side with room to spare. But behind its surreal beauty lies an entire universe of engineering challenges, continuous repairs, and a team working 100 meters above the ground to keep this impossible structure alive. Let's begin. A megastructure above the trees. High above the treetops, 100 meters above the ground, Meller and his colleagues make their daily climb. Their workplace is not a skyscraper or a bridge, but the roof of the largest self-supported hall by volume in the world. This colossal structure holds over 5 million cubic meters of enclosed space, making it one of the largest buildings ever constructed. From orbit, astronauts can clearly see this bright silver dome cutting through the green of the German forest. Hidden in rural Brandenburg, the hall appears like something extraterrestrial, its curved foil-clad skin shimmering like the hull of a landed spacecraft. But this is no UFO. Originally built as an airship hangar, it now stands as the world's largest cantilevered hall, stretching 360 meters long, 210 meters wide, and 107 meters tall. Civil engineers often compare its size using extreme references. The Statue of Liberty could stand comfortably inside, while the Eiffel Tower could lie sideways across its floor. But size comes with responsibility. Meller's team constantly monitors the structure's vast outer skin, checking for leaks, cracks, and foil deterioration caused by decades of harsh European weather. Their daily mission ensuring the megastructure remains safe, dry, and functional for millions of visitors each year. The strange discovery in the forest. If you wander through the peaceful Brandenburg forest, you might expect deer, quiet rivers, and endless pine trees. Instead, out of nowhere, an enormous metallic dome rises from the landscape, an architectural anomaly impossible to ignore. It looks like a misplaced science fiction structure, an alien landing craft designed for another planet. But this massive hull carries a very earthly history. Built using advanced steel trusses and flexible UV-permeable foil, the structure was designed to house gigantic airships under construction. Its lightweight shell covers more surface area than multiple football fields combined, and its curved arch spans 210 meters without any internal columns, an engineering feat only a handful of structures in the world can match. Inside this dome exists a world beyond imagination, a vast tropical landscape with beaches, palm trees, lagoons, and even a rainforest. With a constant interior temperature of 26 degrees Celsius, the building houses Europe's largest tropical water world. Civil engineers transformed a Cold War-era infrastructure into a fully artificial climate bubble capable of supporting complex plant life, humidity levels, and temperature regulation. This is where the surreal meets the structural and indoor island hidden where you least expect it. How an alien landscape was created indoors. Step inside the hall, and the environment changes instantly. Instead of steel and machinery, you're met with tropical humidity, towering palm trees, sandy beaches, and turquoise water stretching across engineered lagoons. This is Tropical Islands Resort, the largest indoor rainforest and water park in the world. Maintaining this artificial ecosystem is a complex engineering challenge. The climate must remain stable minus 26 degrees Celsius, 60% humidity every hour of every day. The structure's UV-permeable shell allows natural light to filter through, supporting thousands of tropical plants without reliance on artificial lighting. Engineers also use sophisticated air circulation systems to mimic natural convection, reducing hot spots and improving energy efficiency. The rainforest includes over 50,000 plants and 200 species from deserts, marshes, and deep jungles. Each plant requires different moisture and sunlight levels. Gardeners and environmental engineers constantly monitor soil conditions, water needs, and plant health to maintain equilibrium. Then comes the water. Over 600,000 liters circulate daily through pools, rivers, waterfalls, and mist systems. Massive filtration units, underground tanks, and powerful jet pumps keep everything operational. Maintaining this indoor world is like running a small city 24/7, 365 days a year. Origins of the megastructure. The hall's history is as dramatic as its appearance. In 1938, the German Luftwaffe developed an airfield here. After World War II, the Soviet Red Army claimed it, using it as an aviation base until 1992. When the Soviets left, the land became a vast, empty wasteland. Enter entrepreneur Karl Heinrich von Gablitz, who envisioned futuristic heavy-lifting airships capable of carrying massive industrial loads. His company, Cargolifter AG, began constructing a gigantic hangar, the hull we know today. Supported by huge steel arches and covered with specially engineered foil panels, the structure became the largest freestanding hall in the world. German citizens believed in the dream. 65,000 people invested in shares. But by 2002, the ambitious airship project collapsed, leaving behind a staggering empty dome. Instead of letting the structure rot, a Malaysian investor saw opportunity. The hull was transformed into Tropical Islands Resort, preserving the engineering marvel while giving it a second life. The conversion required structural reinforcement, insulation upgrades, new climate control systems, and complex water management planning. Decades later, this reborn megastructure now welcomes millions from around the world. Maintaining the giant shell. After 20 years exposed to Germany's harsh winters, the hull's outer skin made of UV-permeable foil has aged. Snow loads, wind stress, and temperature fluctuations constantly strain the surface. For Miller and his rooftop team, maintenance is continuous and dangerous. Each day, they inspect massive foil strips spanning tens of meters across the dome. If a single panel becomes brittle or torn, water can seep through, leading to corrosion, electrical hazards, or temperature loss inside. Specialized polyethylene membranes and reinforced textile strips are cut, welded, and installed by skilled workers and climbers. Engineers also monitor thermal expansion. Because the dome heats up during the day and cools drastically at night, expansion joints must flex safely without cracking. Sensors measure structural movement, helping maintenance teams predict weak points before failures occur. Storms pose even greater risks. Heavy rainfall can push water through microscopic gaps, creating interior leaks. While a rainforest may belong indoors, rain from outside certainly does not. Every leak must be identified and sealed immediately, as the hull's interior environment relies on precise climate control. The result is a constant battle man versus weather fought hundreds of feet above ground to keep the world's largest hull intact. The underground engineering network. Beneath the artificial beaches and rainforest paths lies a hidden world, the catacombs. This underground engineering maze contains the lifelines that power the tropical environment above. Massive pipelines transport heated water, chilled water, and recycled water across the complex. Filtration units, chemical dosing systems, and sedimentation basins operate around the clock to maintain water quality across pools and rivers. Engineers like Alexander Bauer oversee daily water testing using both manual devices and automated sensors. The hull draws water from on-site bore wells. This raw groundwater is pumped into huge underground storage tanks holding 100 cubic meters each. 6 jet pumps, each weighing over 300 kilograms and powered by 30 kilowatts motors, generate the high-pressure flows needed for river currents and surfing waves. Meanwhile, ventilation ducts regulate humidity, preventing mold and corrosion across the entire 60,000 square meters indoor rainforest. Electrical rooms contain thousands of circuits powering lights, pumps, monitoring systems, and heat exchangers. Even animal care is part of the underground operations. The flamingos, turtles, and tropical birds receive specially formulated diets to maintain their natural colors and health. Behind the scenes, it's a self-sustaining microcity, one that only works because engineers keep every system in perfect balance. Daily operations and safety systems. Tropical Islands functions like a massive indoor city with up to 6,000 visitors per day. For such crowds, safety is paramount. Meller's team works alongside security, lifeguards, and technicians to respond to any emergency fires, injuries, or equipment malfunctions. The hull contains thousands of sensors, smoke detectors, airflow monitors, pressure sensors, and sprinkler triggers. False alarms are common, particularly in humid areas where steam can confuse sensors. Teams must quickly inspect and reset devices while ensuring public safety remains uncompromised. Medical emergencies are also a regular occurrence. Families with children, elderly guests, and adventure riders often need assistance. Lifeguards are trained to handle water rescues, and the resort's medical team responds to everything from heat exhaustion to minor injuries. There have even been real water rescue incidents where children were saved thanks to the rapid coordination of staff. Engineering teams also patrol high-risk zones, piping networks, electrical systems, and high-temperature areas, checking for rust, leaks, or structural displacement. Climbers perform high-altitude inspections on roof-mounted pipes, removing corrosion and reinforcing joints. With thousands of daily visitors, continuous humidity, and massive energy loads, keeping the resort safe requires precision, training, and constant readiness. Energy, environment, and public criticism. While the resort is spectacular, environmental critics argue it comes at a cost. Maintaining tropical temperatures in Germany's cold winters requires enormous heating power. The hull was never designed for insulation. It was built to house airships, not conserve heat. As a result, energy consumption is exceptionally high. Heating water to tropical temperatures, powering pumps, and controlling humidity in a 5 million cubic meter space demands vast amounts of electricity. Engineers continually upgrade systems to improve efficiency, installing heat recovery units, sealing insulation gaps, and optimizing air circulation. The hull's size also makes maintaining a stable climate difficult. Warm air naturally rises into the dome's peak, so automated vents release excess heat while drawing cooler air inside. Balancing temperature without wasting energy is an ongoing challenge. Despite criticism, the resort continues expanding. New holiday homes, upgraded water systems, and more efficient air handling units aim to reduce long-term environmental impact. Engineers plan to integrate renewable energy sources and modern heat pump technology to improve sustainability. Tropical Islands represents the clash between human ambition and environmental responsibility. It asks a fundamental question: how far should engineering go to create paradise in places where nature never intended it? A megastructure that keeps growing. From the air, Tropical Islands looks like a growing urban island in the middle of a forest. Every year, new developments sprawl outward: holiday homes, pools, and recreational facilities. In 2020 alone, 135 new homes were added, expanding the resort's capacity to over 2,500 beds. Gardeners like Stefan now manage not only the indoor rainforest, but also 630 hectares of outdoor land. Engineers design new walkways, drainage systems, irrigation networks, and utility connections for each expansion phase. Inside, the megastructure continues aging. Steel, foil, piping, and insulation require perpetual attention. Every bolt, joint, beam, and membrane must withstand humidity, heat cycles, and the vibrations of thousands of visitors. The hall's enormous footprint means inspections can take weeks. Yet, despite these challenges, the resort remains increasingly popular. Over 1.2 million visitors arrive each year, drawn by the surreal experience of a tropical world inside a European forest. For the operators, the goal is clear: become Germany's #1 holiday destination. What started as a failed airship dream has transformed into one of the greatest examples of adaptive engineering reuse. The hull is not just maintained, it is reborn continuously, adapting to new ideas and new generations of guests. The tropical island's megastructure is unlike anything else on Earth, a building so vast it forms its own climate, its own world, and its own engineering reality. What began as an abandoned airship hangar has become a thriving tropical universe sustained by thousands of workers, engineers, and visionaries. As we've seen, maintaining this hull is a constant battle against time, weather, corrosion, and sheer scale. Yet, it stands as a testament to human creativity and engineering ambition. If you enjoyed this deep dive into megastructure engineering, don't forget to like, share, and subscribe to Civil Engineering Edge.